This is Electric Universe Eyes, and today I present to you the rapid electrical formation of stone spherules, the scalability of the results, and the similarities of the internal and external structures of the spheres with naturally occurring concretions. Published results by Vemasat Laboratories. In 2004, plasma physicists C.J. Ransom and Thornhill carried out independent experiments which tested the effects of electric arcs on various minerals and sands, along with round craters or various types, including flat-bottomed craters. Electric arcs on many materials also created small spherules. These stone spheres were formed electrically not only using many types of minerals, but also using different voltages and for different durations, from 50 to 30 seconds. The spherules appeared on the surface, under the surface, and on the rims of craters. The types of minerals tested are common to the surfaces of the rocky planets in the solar system: silicon dioxide, iron oxide, talc, calcium carbonate, lava sand, and hematite. Of particular interest to the authors were the small blue 1 mm hematite spherules formed rapidly by discharging an electric arc on hematite powder. The result matched the images of the plentiful blueberries on the surface of Mars, being returned at the time from the red planet by the rover Opportunity. These lab results created blueberries, along with the electrical generation of craters, revealed that there was mounting, powerful evidence of electrical scarring not only on the planet Mars, but on all the rocky bodies in the solar system. Planets, moons, and asteroids likewise are covered with the familiar round, clean, flat-bottomed craters, so mysteriously free of fallback debris. The results were published by the IEEE, APS, and the Open Astronomy Journal. Later, Stephen Smith wrote widely read papers on the New Zealand's Moraki boulders, recently discovered Chinese concretions, and Martian blueberries. He expertly examined the evidence both from the structure of the concretions and from the surrounding rock strata, and made a bold argument for an electrical, non-sedimentary theory for their formation. Quote, "The conventional theories," he wrote, "are based exclusively on chemistry and mechanics, but there is another phenomenon that produces spheres: electric discharge. Electric discharge tends to produce spherical layering and a distinct equator and pole, because the electromagnetic force squeezes perpendicular to the current that creates it." 1.1 Scalability of Vemasat's results. In his paper, Laboratory Modeling of Meteorite Impact Craters by Z-pinch Plasma, Dr. C.J. Ransom wrote a brief history of the use of lasers and spark machining on metal surfaces to reproduce craters on a sub-millimeter scale. Dr. Ransom's work expanded the type of substances used for experimentation and also simulated craters to over a centimeter in diameter. Regarding the scalability of the results, C.J. Ransom summarized, quote, "Although Dietz mentioned only terrestrial lightning scale discharges, Alfvén indicated that laboratory results can be extrapolated over 20 orders of magnitude to include effects seen in deep space. Peratt noted that experimental plasma effects have been shown to be scalable over 14 orders of magnitude. Others have also noted that laboratory plasma experiments may be scaled to astrophysical phenomena. In plasma-generated craters and spherules, Ransom and Thornhill observe, quote, "Spherules were created in a number of materials. Materials of particular interest in the studies included magnesium silicate hydroxide, or talc, and silicon dioxide. Once determined, we found that specific materials and conditions always produce spherules. We also tested various carbonates and iron oxides. The experiments produced both individual spherules and joined spherules." End quote. Because of both the scalability and the consistency of obtaining results in the variety of materials tested, the stone spheres created in the lab have deep, unsettling implications for the study of concretions. Concretions in nature occur in sizes ranging from microscopic examples to tourist destinations boasting 20-foot concretions resting on the valley floor. 1.2 List of features observed in lab created stone spheres. Lab generation of stone spheres using plasma discharges have so far coincided with the parameters necessary for the production of crater-like disturbances of the surface and have resulted in a wide variety of forms. As said, lab spheres can be solid, hollow, fused pairs, fused multiples, and can even result in hemispheres with a flat plane. Other notable features include distinct poles, polar markings, possibly ripples, equatorial bands or bulges, radial layering, a round outer scar, smooth surfaces, and smooth, rough hemispheric differences. Here we have a comparison of the lab results to geological observations. Solid, hollow, fused pairs, fused multiples, hemispheres, smooth surface, round outer scar, radial layering, equatorial band, equatorial bulge, polar markings, possible rippling effect on surface, many materials tested, including silicon dioxide sand, lava sand, hematite, magnesium silicate dioxide, and on meteorites. Spheres formed on surface or below surface, flat plane, silicon dioxide sand fused without cement. Discrete sphere formed in neat depression, messy or globular form. Smaller fused spheres attached. Fulgurite shown at left is from a lightning strike. Hemispheric differences. Lab concretions are sometimes discrete spheres found within a depression, or they are formed in numbers around the electrical scar. Lab concretions form on the surface, or they may form below the surface. More detailed scientific descriptions of concretion deposits may include a description of a progression of external structures found side by side in the nodule layer. Concretions may be round, then beyond a certain size become obloid, then begin to flatten, and then become more plate-like or amorphous. In the example below, the concretion structures progress from nodules to logs, which are easily mistaken for petrified trees. Reproducing a progressive morphology is another area in which lab experiments have imitated nature, though results remain preliminary at this time. 1.3 Experimental Arrangement. In Laboratory Modeling of Meteorite Impact Craters by Z-pinch Plasma, C.J. Ransom described the experimental arrangement. Quote, "Plasmas were created in a container with a discharge probe that could be moved in the vertical direction between experiments. The vertical distance from the probe to the sample could be set at 1 centimeter to 30 centimeters. The probe was also movable along a path of 10 centimeters during an experiment. The probe could move plus or minus 1 centimeter perpendicular to the horizontal path. Some tests were run using AC and others using DC. Discharge durations for experiments not using pulsed discharges were between 1 and 20 seconds. Samples were placed on metal plates that could be switched in DC experiments to act as the cathode or the anode. The sample containers were either metal trays, thin non-conducting trays, or non-conducting trays that used a conductor at the edge. Samples were generally between 4 millimeters and 12 millimeters. We used powders and solids. Most plasma discharges were created with a 12,000 volt, 120 milliamp supply that could be run with a voltage doubler. Small voltage supplies and a 100,000 volt microamp discharge coil were used to develop a wide variation of plasmas." End quote. On the top right, lava sand, here with calcite, did not form a sphere in some conditions. Instead, a fulgurite was generated, exhibiting a rough symmetry around a line or plane. Middle right, electric discharge can produce spherical layering and a distinct equator and pole, because the electromagnetic force squeezes perpendicular to the current that creates it. And bottom right, a plasma discharge may form spheres in a crown-like feature around a crater and or scatter them above the surface. Because of the scalability of electrical phenomena, the successful generation of stone spheres across so wide a variety of minerals, and because of the similarity of lab forms to natural forms, it is now our intention to ask whether there is a fully electrical explanation, not only for concretions, but for fossiliferous concretions. The purpose of this paper is to take the results and publications from Vemasat labs further by applying the findings from the electrical experiments to the abundant fossiliferous concretions found all over the surface of the globe. In particular, the interest is in the three-dimensional soft-bodied fossils encased within the concretions. Our first example is a fossil horseshoe crab concretion from the Maison Creek Formation, image by TV Testa. 2. Soft-bodied fossils and concretions found on all continents and covering ocean floors. What is a soft-bodied fossil? Soft-bodied fossils are the ancient remains of invertebrates preserved in stone. Examples of invertebrate animals preserved in the fossil record include jellyfish, worms, insects, spiders, bivalves when extended from their shells, centipedes, incubating eggs, and many crustaceans. It also refers to the preservation of delicate traces of plant life cycles such as stems, flowers, leaves, and pollen grains. Soft-bodied fossils can be casts or impressions, or the living tissue may have been mineralized. They are preserved in articulated positions between laminate layers, or they may be three-dimensionally preserved. The structures of the animals and plants may be so exquisitely preserved that they are just as useful for studying the internal structure of the creature as a living specimen. Some soft-bodied fossils are preserved in microscopic cellular detail, though turned to stone. Soft-bodied fossils may also refer to vertebrate fossils when tissues have been preserved. For example, in Bear Gulch, an exceptional Carboniferous platencult, James W. Hagedorn reports that, quote, the preservation of veins, skin pigments, organ pigments, gut contents, sexual organs, and other soft tissues has allowed reconstruction of the life habits, feeding strategies, sexual dimorphism, trophic structure, and evolutionary history of numerous taxa from this deposit, end quote. He later adds, dark skin color patterns, intact venous systems, as well as liver, spleen, and eye pigments also occur in many fish specimens. Grogan and Lund, 1997. More rarely, muscles are phosphatized. Lund et al., 1993, end quote. Again, these can be preserved as molds, casts, or petrified remains. In China, SEM studies of the soft-bodied fossils from the Chengjian Biota, Meoshishan, Chengjian County reveal structures of the guts of arthropods and worms in which the soft tissues have been preserved as assemblages of concretions, as thick mineralized films within the fossil. The film is made up of iron oxide and pyrite microspherules. 2.1. Soft-bodied fossils and concretions are found on every continent and on the seamounts in commercial quantities. Assemblages of concretions containing soft-bodied fossils are found all over the world, and in some abyssal plains they have been discovered to cover up to 70% of the ocean floor, though these most often have a shell nucleus. The list of sites below is representative only. Africa, the Morocco Fezuta Formation, discovered in 2010, contains 1,500 soft-bodied fossils, some of which are preserved in subcellular detail. The concretion shown is approximately 1 meter in length and contains an incomplete Thule monster. This video was released by Yale University. Australia, the Gogo Formation in Western Australia is rich in concretions containing Ordovician fish and crustaceans. Europe, outstanding specimens of three-dimensional fossils have been collected for decades from the Montsoulès mines site in France, and the fossils have been invaluable in studying the internal structure of ancient arthropods, crustaceans, arachnids, and annelids. Image via nonphotosdefamille.com. Asia. These fully articulated fish fossils with membranes preserved in concretions shown are from an unknown location in China. North America. The Maison Creek biota contains more than 400 plant species and more than 320 animal species preserved in concretions. South America. Extensive soft tissue is preserved in the concretion of the Santana Formation in northeastern Brazil. Antarctica. A horizon of fine-grained sediments on the James Ross Island is the site of concretions ranging from 5 to 244 centimeters in diameter. These contain well-preserved fossils, including crabs. Pacific seamount and Indian Ocean floor. Manganese nodules have been discovered on the floors of the Indian, Atlantic, and Pacific Oceans. These nodules are concretions which possess a nucleus that may be any solid object, but is often biological. Some of the biological nuclei are soft-bodied, such as a sponge or a delicate microfossil, radiolarian, or foraminifer. 3. The omitted variable, electricity. Both in economics and in the sciences, there is a problem in getting accurate or worthwhile outcomes when all models or systems omit a variable in the inputs for the models or systems. In his review of the final order draft of AR5 by the UN, Alec Rawls wrote, quote, My training is in economics, where we are very familiar with what statisticians call the omitted variable problem, or when it is intentional, omitted variable fraud. Whenever an explanatory variable is omitted from a statistical analysis, its explanatory power gets misattributed to any correlated variable that are included. The problem is manifest at the very highest level of the analysis and is built into each step of its analysis." End quote. Geology as a system or model begins with the axiom that present-day forces are responsible for the great majority of the features of the surface of the Earth. Rivers and water under influence of gravity, winds, volcanoes, earthquakes, and glacial movements were all in action in the past and make up the primary inputs in the system. In this model, at all levels of the analysis, these factors are expected to be chief forces responsible for shaping our present landscape, along with the mineral and water deposits well below the landscape. Geology is also a system which introduces deep time. Spans of tens, hundreds, and thousands of millions of years are required, and assumed to explain how the present forces could have enough time to shape the continents, mountains, valleys, basins, oceans, and deserts we see. Geology is not, according to geology textbooks, a hard science because the scientific method cannot be applied. It is said that the, quote, experiment has already been performed in the distant, inaccessible past, but what geologists can do as scientists is examine the results and advance plausible hypotheses based on the recognized inputs to the present geological model. This inquiry is therefore not geology in the modern sense of the word. It cannot be because it is not limited exclusively to those inputs and variables. Quote, "Noah's mission is to understand and predict changes in the Earth's environment from the depths of the ocean to the surface of the sun." End quote. This statement appears to acknowledge that the Earth is not a closed system, but is in continuous, dynamic adjustment with its space environment. Rather, this inquiry admits a previously omitted variable, electricity. Specifically, the omitted variable introduced in this inquiry is electricity on a cosmic scale, which is caused by mega-ampere plasma events in the space surrounding the Earth. Everyday experiences readers may call to mind which give some sense of the scale of these plasma discharges are the beautiful auroras in the northern and southern hemispheres. These auroras are caused by electrical currents which excite the thin air in the upper atmosphere, so that the excited gases give a pleasing, otherworldly glow. Auroras pass through the various formations, often inspiring the viewer with a sense of awe, which borders for some on a spiritual experience. Importantly, for our inquiry, these auroras are also to be observed on other planets. In particular, the gas giant planets have leaping, spectacular auroras on their poles, and these auroras are many times the size of the Earth. Furthermore, lightning storms of stupendous Earth-sized proportion rage on the gas giants, so that there are constant lightning signals picked up by spacecraft and even sometimes on the AM radio. Evidence in the rocks for these kinds of cosmic scale electrical forces which can be observed in the solar system is examined. Laboratory techniques and experiments using plasma and electricity to deposit, engrave, sculpt, or otherwise alter common materials are admitted for their explanatory power in understanding the history of the planet Earth. The techniques and processes under consideration here include 1. Lab creation of spheres and surface scars. 2. The effects of lightning bolts on sand, soil, and rock. And 3. Low-temperature nuclear transmutations. And 4. Plasma deposition and engraving and electro-winning processes are cursorily referenced as well. The study of exogenic fulgurites, the effects of lightning bolts and downed power lines on rock, soil, and sand. When lightning strikes the Earth, high temperatures melt the surface materials and surprising forms are sculpted by the electrical arc in its fields, just as the experimental arrangement by Vemasat Laboratories, which form craters and spheres, has many variables which can be adjusted. The formation of a fulgurite by natural lightning has many variables which affect fulgurite formation. Some of the possible variables of natural, large-scale electrical discharge events are polarities, charge differentials, current flows, material conductivity, duration, intensity, and charge capacity from the surrounding area. Lightning strikes which form below the surface are known as fulgurites, and lightning strikes which may travel along the surface of the ground and cast up liquefied materials are called exogenic fulgurites. Along with the experimental results by C.J. Ransom et al., fulgurites created by powerful lightning bolts in sand, rock, and soil present an opportunity to study the entire surface of the Earth in a manner much closer to the scientific method, because they happen in real time and are reproducible. We continue by noting some basic features of the electrical effects on sand, rock, and soil, which we can later compare with the strata of the 5 previously mentioned geographical sites where fossiliferous concretions are found. 3.1 Effects of lightning on sand. Lightning strikes on beaches and deserts create fulgurites from the clean, dry sand, which are more easily spotted because they are easier to reach on foot and because of the lack of covering underbrush. They are also easier to retrieve intact because of the loose, sandy surrounding material. For this reason, they are the most familiar and available for study. Sand fulgurites are hollow, often branching tubes with a glassy interior and an exterior that is made of sand grains fused to the surface. The surface can even include a conglomerate of larger pieces of pebbles and rocks which are fused to the fulgurite. All the transition rock between the melted quartz layer inside the fulgurite and the outer layer, which is only lightly fused together, has many gradations which are, at least partly, the result of dropping temperatures radially from the center of the fulgurite. 3.2 The effects of lightning on rock. Less accessible fulgurites form when lightning strikes mountain peaks or enters a subsurface rock layer. These fulgurites are difficult to reach on foot and are fused into or onto the surrounding rock. Fulgurites in rock were mentioned by early explorers such as J.S. Diller and Alexander von Humboldt, who found them on mountain peaks in Oregon and in Central America. In Fulgurite in the Sierra Nevada, Christopher A. Libby writes, quote, "It appears that the composition of many volcanic rocks is favorable to the formation of fulgurite. This hypothesis was reinforced by my observation of fulgurites atop Mount Thielsen, South Sister, the Husband, and Three-Fingered Jack among the volcanic of peaks of Oregon's Cascade Range. Fulgurite occurrences in these areas appear as black or greenish, bubbly crusts on the dark volcanic rocks on the upper several feet of those peaks. I was surprised to find in the summers of 1984 and 1985 that fulgurites are relatively common on the granite peaks of California's Sierra Nevada. In Sequoia and Kings Canyon National Parks, I found fulgurites atop the following granite peaks: Thunder Mountain at 13,588 feet, Sugarloaf 8,002 feet, Whaleback 11,726 feet, Mount Stewart 12,205 feet, Big Bird Peak 11,602 feet, and Peak 11,840 feet on Glacier Ridge. The Sierra Nevada fulgurites are similar in appearance to those in Oregon. Black, green, or white bubbly crusts on the surface of the rocks. The crusts appear on the topmost rocks as veins running down the summit blocks and in pockets below the topmost rocks. Fulgurites seem to be confined to approximately the top 2 meters of the peaks." End quote. 3.3 The effects of lightning on soil. On April 20th, 2002, in Denton, Texas, a lightning bolt struck a transformer and downed a power line. According to observers, the downed line snaked across almost 60 feet of a residential lawn and continued to spark for a period of 30 minutes. The line, along with additional energy from the lightning, burned a long glassy trench into the clay soil which terminated into the street, blasting apart and liquefying portions of the concrete curb. George Maxey of the University of North Texas, in his peer-reviewed paper on the event, wrote, quote, "Fulgurites and similar structures produced by downed power lines have characteristics of both igneous and metamorphic rocks. Their vitreous interiors are igneous in origin, while their crusty exteriors are contact metamorphic structures. Soil samples collected from around the burn scar contain numerous hollow stone spheres, measuring 1 to 6 millimeter in diameter. In the above photograph, orange-brown, quote, discoloration appears on the top of the pipe, along with possible oxidized remains from the grass. Other instances of fulgurites forming in a soil medium have been documented. These fulgurites were described as bubbly crusts of green, brown, or even white, like the exogenic fulgurites on mountain peaks. An Oswego, New York fulgurite had, quote, drapery or sheet forms close to the effusion craters, and spheres of green, brown, gray, and white. Many delicate forms, such as, quote, wires and hollow fused drops, were believed to have formed as they cooled in the air before reaching the ground. Differences in texture on opposite sides of the exogenic fulgurites were noted. 4. Transmutation and the temperatures involved. Despite the stigma attached to cold fusion in the general public discussion, some readers may already be aware that in 2009, the United States Navy announced success in producing low-energy nuclear reactions. Other scientists have been working on the problem without much thanks or funding in the decades since 1989, when the U.S. Department of Energy announced that cold fusion was an error and could not be reproduced. Among them are Drs. Tadahiko Mizuno on the right and Akito Takahashi, who have published results from years of lab work showing nuclear transmutations have taken place as evidenced by neutrons, excess heat, X-rays, and altered compositions of the elements. For example, CS coating on PD rods in an electrolyte at 343 K and 10 ATM has transmutated to PR. Methods have generally involved packing palladium rods with deuterium and running electricity through the rods in an electrolyte. The reason the rods are packed with heavy hydrogen is to theoretically place the atoms as close together as possible in order to, quote, assist the nuclear fusion through the use of lattices, with the expected result of obtaining excess heat from the fusion of two H atoms into a He atom. What was discovered instead while seeking to produce helium and excess heat is that the real cause of the effects was in the fusion and fission of heavier elements. Other scientists have reported and published success in obtaining nuclear reactions at low temperatures using wires. For example, research in, quote, pyroelectric fusion, or exploding wires, has been carried out by Greek scientist Theophanes E. Raptis. In his experiments, a transient pulse is run through, quote, loaded wires. It has been observed that the wires fragment first in the center and then symmetrically along the remaining halves of the wire. His hypothesis is that the reaction occurs at certain harmonics along the wire, as if it were an antenna. The reactions are, quote, responsible for X-ray and even neutron emissions, end quote. Slides are from an online presentation used by permission. The key question behind such experiments is as follows. Does the initial energy support both the plasma formation, the kinetic energy, and the high activation energy, white light emission, of the fragments? Theophanes E. Raptis. These are remarkable results, and from them we can observe and deduce certain principles potentially at work in the low-energy nuclear fusion process. We see that both resonances and the heavier elements are present in successful atomic fusion experiments. However, packed deuterium and even exploding wires are only generally helpful in our present study of fossils because they are not very natural conditions. One can hardly speak of bone, shell, or tissue as packed or dense. Bone and wood in particular are quite spongy and porous, and nothing at all like a deuterium-packed palladium rod or wire. 4.1 Closer to nature. Advances in transmutation using powdered nickel. The recent work of André Rossi in obtaining stable low-energy nuclear reactions is much closer to conditions in nature. Dr. Rossi uses powdered nickel, trace catalysts, and mini hydrogen tanks. He reports that at the melting point of nickel, the reaction ceases because at those temperatures, the nickel no longer has the powder form necessary for the reaction. The granulated state of the nickel is much closer to approximating the soils, sands, and silts on the surface of the Earth. And nickel is one of the most common elements in the Earth's crust. Dr. Rossi has published his results and demonstrates of his working energy catalyzer, ECAT, were held in Barcelona, Italy, in October of 2010 to qualified witnesses. He has since devoted all of his time to the further development and production of home devices and left the theoretical aspects of the discussion of his innovative energy source for a later time. The U.S. Patent Office does not give patents for cold fusion energy sources, stating that cold fusion is a, quote, perpetual motion machine and, quote, the usefulness cannot be demonstrated. Dr. Rossi has, however, obtained a European patent and is working on making a device as inexpensively as possible. As an inventor, his aim is to make it available to more people through low prices and also to make an advanced strike on competitors and reverse engineers through streamlined, mechanized production already in place when his invention reaches market. Despite the highly politicized atmosphere and the legal agreements which prevent full discussion of a product before its release for sale, we proceed with caution to examine the implications of the ECAT for the earth sciences. Publications describing the structure of the transmuted copper particles are still pending. When asked about the forms of the copper particles and whether he observed microspherules after the reaction, Dr. Andre Rossi wrote, quote, "The copper has been detected by means of a SEM and a SIMS, and it has been found in form of amorphous grains. But this is an issue still under probe. The effect is much more complex than imagined originally." End quote. Reported operating temperatures for the ECAT, the lowest safe stable reactions, occur less than 200 degrees Celsius. Recent increases in operating temps, 600 to 1,000 degrees Celsius. The melting point of nickel is 1,455 degrees Celsius. Comparing the melting points of the common minerals which comprise fossiliferous concretions in Table 2 with the operating temperatures of the nickel to copper reaction in Table 3, we see that the process of transmutation can be well below the temperatures which would liquefy those minerals. Fossilization, if an electrical effect, would not necessarily cause the sand, calcium carbonate, or iron oxide to melt. This is the reason the concretions can appear sedimentary and not strictly like a fulgurite from lightning. We also saw that some of the lab-generated stone spheres formed, it would appear, at much lower temperatures in the intensifying azimuthal field of the Z-pinch. 5. Methods. 5.1. Define geographical areas for study using county lines. Only carefully defined areas are marked out for the present study so that the attention is always on the actual evidence and not on creating a new, quote, system which replaces the old. This will satisfy the standards and methods both of James Maxwell and Georges Cuvier. The regions marked out for the field of this investigation are Mason Creek Formation in LaSalle County, Illinois, Peoria and Fulton counties on the western bank of the Illinois River, the San Rafael Swell and surrounding region of Emery County, Utah, Rock City, Kansas in Ottawa County, the Mid-Pacific Seamount area, less than 3,000 meters depth, and the Kesey Formation in Columbia and Washington counties, northwest Oregon, along with the adjacent Lincoln Creek Formation in Cowlitz and Lewis counties, Washington state. 5.2. Compare satellite imagery of Earth with electrical scarring from lightning and with man-made Lichtenberg figures. It has already been observed that while the lab-generated stone spheres are associated with circular crater scars, spheres are also formed in the same minerals within the formation of other electrical scars. They were present in the soil around the long burn scar left by the lightning and power line in Denton, Texas, and they have also been reported occurring around the branching Lichtenberg scars left by lightning on the ground. 5.3. Travel to area under study. Examine local stratigraphy for similarities to fulgurites, exogenic fulgurites, and other evidences of high temperatures in the rocks. 5.4. Ask new questions based on known electrical processes. Technology is rapidly advancing, and methods of using plasma and electric currents to deposit materials, to engrave surfaces, or to scar surfaces have been well researched and applied. Opportunities to compare the properties and appearances of crystals and plating which were formed in an E field or electric current with the properties and appearances of crystals and rocks in nature abound. For example, electrowinning is a simple process which creates some unusual forms of crystals. And below is a detail from the internal structure of a concretion recovered from the Thermopolis Formation near Cody, Wyoming. 5.5. Observe and describe 4 specific features of the surrounding geology. Lateral continuity, when there is no lateral continuity, and when there is lateral continuity over hundreds or thousands of square miles. 2. The location of caves. 3. The presence of uranium in discrete layers or objects. 4. The presence of microspherules. This paper has been written in an expandable format, and these features of the landscapes will be noted without explanation at this time. 5.6. Document native fossil legends from the area. Another key to examining the question of fossilization is to study the worldwide legends and myths of native cultures. This is the approach to the history of the solar system taken by Wallace Thornhill and Dave Talbot in The Thunderbolts of the Gods and in The Electric Universe. Adrienne Mayers emphasizes that this was also a method of inquiry used by the great French naturalist and founder of vertebrate paleontology, Georges Cuvier, 1769 to 1832, in his work Researches on the Revolutions of the Globe. One of his many foundational contributions to paleontology was establishing the fact of extinction, without which a directional history could be read from the Earth's crust. He took into account the oral and traditional legends of the past, finding that there was indeed a theme running through all the myths, witnessing to worldwide catastrophe and renewal, and in some cases successive epochs ending in cataclysm. Much of the research regarding fossil myths on several continents appears here through the work of the outstanding scholar and authoress Adrienne Mayers. There is certainly more research to be done, particularly for the Sahara Desert and South America, and she also has noted that her work in North America is not exhaustive. Still, it is worthy to note that in Europe, the early Greeks and Romans believed that an era of giants, monsters, and large beasts was ended when a war between Zeus and Aphrodite and the Titans turned them to stone and buried them where they lay, in a clash of cosmic thunderbolts. The traditional locations where these battles were said to take place correspond with major recent fossil discoveries in the Mediterranean. Thunder beings and lightning bolts are a stunning leitmotif in North American Indian fossil legends as well. Lightning was given as a gift to turn the large creatures to stone in order to make the world safer for the Indians, in one of many fossil myths. Some cautions exist. The number of tribes and languages in North America at the time of the arrival of the colonists has been estimated to be over 2,000. The difficulty in finding pre-Columbian myths from a tribe in a precise area would be enormous. But it is hoped that modest progress can be made in finding fossil legends from general areas. 5.7 Record the presence and types of petroglyphs and pictographs. The interdisciplinary approach to understanding the surface of the globe originated by Georges Cuvier when he collected ancient native myths and legends has been carried on by later scholars. In 2000, a small group of astronomers, physicists, and mythohistorians met in Portland, Oregon to discuss the evidence for electrical effects in the solar system. Among them was Anthony Peratt, plasma physicist and colleague of Nobel Prize laureate Hannes Alfvén. His presentation included drawing figures upon the board that looked like stacked arrows, stick figures, and rayed wheels. The mythologists identified them as familiar rock art figures. A Canberra Times article by Wal Thornhill continues, quote, "He was sketching plasma instabilities that occurred in experiments with the giant Z-pinch machine at Los Alamos National Laboratory. For an instant, it concentrates 80 times more electrical energy than the combined power stations on Earth into the volume of a cotton reel. He thought the shapes were known only to a few scientists, but apparently the ancient petroglyph artists had been sketching the life cycle of a cosmic thunderbolt. That interdisciplinary meeting mobilized a worldwide network of scholars and volunteers to document the precise location, appearance, and orientation of prehistoric petroglyphs. We now have data on hundreds of thousands of petroglyphs, and a clear pattern has emerged. They are oriented so the lower sky toward magnetic south is blocked. The ancient artists were shielding themselves from lethal synchrotron radiation at the heart of the electrical discharge. The correspondence between the strange figures inscribed in solid rock and plasma instabilities is almost total." End quote. Later, in December of 2003, Anthony Peratt published Characteristics for the Occurrence of a High-Current Z-pinch Aurora as Recorded in Antiquity, with IEEE transactions. This paper compares the plasma formations in the lab with rock art from all over the world. This paper carefully compares the predominating geometry of the changing forms of plasma instabilities with worldwide petroglyphs and finds they are highly similar, if not perfect likenesses. The startling possibility is that the people who made the rock art were witnesses to auroral forms caused by millions of amperes coursing through the atmosphere above them. These rock art forms and their locations and areas where fossiliferous concretions are found are also represented in this study. Equipment: laptop, camera, Chevy pickup truck, 32-foot camper trailer, microscope, hydrochloric acid, scales, laminate sheets, beakers, tile wet saw, sandpaper, permanent marker, and Ziploc bags. Vemasat Laboratory setup listed previously. End of part 1. And that concludes this narration. If you are interested in Anthony Peratt's published work, Characteristics for the Occurrence of a High Current Z-pinch Aurora as Recorded in Antiquity, here's a link for you to click. I narrated that too. As always, thank you for listening, and I hope you learned something new. Au revoir.